Alright, so first today what we're doing is looking at the sum and product of functions. Should actually be sum difference in product. So the sum just some way of writing it. So if it's written like this, f plus g of x, what that actually means is that you add those two functions together. Alright, so it's just adding them together. Now, the domain of f plus g would equal to where the domains of f and the domains of g where they intersect. Now that might seem a little bit funny, but if we have two functions, f and g, so I'm going to have one of them, so it's this, and that's f, and the next one I'm going to have is g, and g goes like this. So f plus g of x just means to add these two things together. Now, when you look at this, so there should be another asymptote here. When you look at this, you can see there's kind of three sections split up by those asymptotes. And over here, where the red is, G is, there's no F to add to it. And again, on this right-hand side, over here where this blue is, there's no red or G to add to it. So when we're adding these together, we can only do it in this middle bit here. So we would then, whatever it ends up being like, so we would add that. So here we add, so we get something there. There we add, we get something there. Zeros there. And then here we're going into the negatives. So it comes down, and so we'll end up with something that goes like that for f plus g. And so you can see then that the domain of f plus g is just in this bit here between those two asymptotes, which is where the domain of f and the domain of g, where they overlap or intersect. Got that. I'll rub that off. I'll rub the graph off. Alright, so difference is the same kind of idea. Alright. And so it's written as f minus g of x, f of x minus g of x. And again, the domain, for the same reasons that I've described before, the domain of f minus g has to be where the two domains overlap, but you have to have something to subtract from the other one. So if one of them doesn't exist in that spot, then it's a bit hard to subtract. So, for example, one is, so here's my f, oops, and then I might have, let's go have g go like, oops, no, it doesn't matter, yeah, that'll do. And then we've got g, and f minus g, so I'm take f and I'm taking away g from it. So if I'm taking away, I'm coming down. So in the green, take that much off. Go through 0 there, take that much off, take that much off. So I end up with something that goes like that. And this one's continuing down. All right, so again, we've got to have some blue to take away, we've got to have some blue here to take this red away from. So we can only have a domain of our f minus g, it's got to be up that way. All right, got that? All right, and the last one is product. So it's product is simply when we multiply things together, and the way that's signified is they use a dot rather than a multiplication. F dot g, so that means f of x times g of x, and for exactly the same reasons why the domain of the difference and the sum has to be where they overlap. Oops. The product's the same. Again, you've got to have an f value and a g value to be able to multiply together, because if something doesn't exist at that point, then you haven't got anything to multiply it by. Alright, so I'll do that. So let's have f, let's make a g. Let's make this go through 1. That'd be nice. And let's have this go back. Let's go through minus 1. Sorry, I'm just talking to myself. Don't worry about me.
That's all right.
Alright, and here's G. So again, we're going to multiply these things together. So down here, there's no red here to multiply by the blue, and the same over here, there's no blue to multiply by the F. But if we go here, 0 times whatever that number is 0. Over here, 0 times whatever that number is 0. And that number times by itself is, I don't know what, it's a fraction, so it's a smaller fraction, isn't it? And so this is going to go something like that. All right, so we can do that with equations as well. So let's have a look at some. All right, I'll rub that off.
Mm-hmm. Class tonight?
Yep. Not many in Year 12 methods.
Pardon?
Not many in Year 12 methods.
Really?
Yeah.
All right.
Alright, so let's have a look at the solutions. So f plus g of x simply means that you add these two together. So f plus g of x is simply the square root of x minus 2 plus the square root of 4 minus x. And there's really nothing more we can do there with that. Now, our domain, we're asked for the domain, so the domain of f is x greater than or equal to 2. And the domain of g is x less than or equal to 4, so what we're looking for is where those two intersect. So, greater than or equal to 2, if you're not sure, quick sketch, greater than or equal to 2 is there up, less than or equal to 4 is there down, where the two things intersect. They intersect between here and here. So our domain then is when x is between 2 and 4. I'll just squeeze this in a bit. Not to worry. All right, F dot. Oops. So the product of them, simply when you multiply the two things together, so we've got that. The domain is
The same?
same, yeah. Right, it's got to be where they overlap. So for all of them, it's always when they overlap. All right, now this last one, f plus g of 3, simply means, what do we do?
Sub x for 3.
Sub x for 3. So we've got f plus g over here. So, written it quite correctly. So f plus g of 3 then would be the square root of 3 minus 2 plus the square root of 4 minus 3. So it's the square root of 1 plus the square root of 1, which would be
1? No. Good damn.
there's a 1 in there.
Square root of 1 is 1. Oh, no. What time do I have?
All right. All right. Now, I did this before when I showed you the graphs, but I just want to write it down and emphasise it, a thing called addition of ordinates. So, on the exam, multiple choice questions in particular might need to use this, although it has been in a written answer question used it as well. But addition of ordinates, people get confused by it, but you'd use addition of ordinates when you want f plus or f plus g or f minus g. All right, people get confused about it. What does it mean? It means that you add the y values together. Now, it's add when it's f plus, but of course it's but we need to subtract when it's f minus g. So you just take an particular x value and then you add those together to get the new y value. as I said, multiple choice, there's been lots of multiple choice questions which say which one of the following could be f plus g when you've been given graphs of f and g. Alright, so let's look at an example. Alright, so you might be given a couple of graphs. In this case, you're given what the equations are, but you might not necessarily be. And then you're asked to pick which one of or draw f plus. So you start off and just pick some x values. So this x value here, you've got 0 plus 0, so you're going to be going through there. Here you've got 1 plus 1 for the y values, for x equals 1. 1 plus 1, so that's 2. It's up there. Over here we've got 4 and 2. So we've got to add 2 onto the top. Or if I take this in the middle here, let's get some more points. Got to add that much. Take that, got to add that much. And so you get something that curving around something like this. And so the green one, oops, is f plus g. Now sometimes with in the multiple choice with some of the graphs that they give you, they like to give you a little bit trickier stuff there. So you just go with what you kind of know. And so always ones which go through axes here, the x-axis, and that's always a good one because you always add in 0, which in this case 2 lots of 0. Where they cross is always a good one because then it's easy. And so then you just got to kind of go and look at those patterns and then pick which is the best option if it's a multiple choice question. Alrighty. Anything about any of that? Nothing too new in there. All right. Exercise 1D on your work plan.
Which one's the textbook?
Nobody has the textbook.